Since the launch of ChatGPT, there has been a lot of hype surrounding the growth of AI. Many experts predict that in a few years, artificial general intelligence, or AGI, will be widely available. OpenAI's GPT-4 is said to bring us closer to that dream. However, there is a significant reason why AI may not take over the world just yet. A fatal flaw in the training of GPT-4 serves as a reminder that it will take a long time to create AI that can truly think like humans. This video discusses that fatal flaw and how close we actually are to AGI. Generative Pre-trained Transformer, or GPT, is a revolutionary development because of how different it is from previous language processing models. It's a generative system, meaning it creates unique and original results that are broadly similar to the data researchers trained it with. Additionally, it is pre-trained, which means that its knowledge base is made up of data from different datasets. Lastly, it is a transformer system, meaning that it identifies patterns in text and predicts logical and human-like responses. This is how GPT manages to mimic human-like intelligence and impress millions of users around the world. But when OpenAI released GPT-1, they may not even have expected how quickly the software would become popular. It became, as many reviewers put it, the world's first useful chatbot. In June 2018, OpenAI launched GPT-1, the first language processing model based on generative pre-training. They pre-trained GPT-1 with the Books Corpus dataset, which consisted of about 7,000 unpublished books. GPT-1 was the most advanced language processing model at the time. It had 117 million parameters, making it the best at what it did. It performed admirably in testing, outperforming all previous models in 9 of 12 tasks. But perhaps the most impressive thing about GPT-1 was its zero-shot performance. A language processing model's zero-shot performance is how well it can do tasks with few or no examples. GPT-1 could do things like answer questions and figure out how people feel without being trained to do those things. This proved the superiority of pre-generative training in developing language processing models and kickstarted the AI wave we're witnessing today. Shortly after the success of GPT-1, OpenAI launched GPT-2 in February of 2019. GPT-2 was meant to be an improvement on every aspect of GPT-1, and the researchers at OpenAI outdid themselves. This model got all of its information from web text, which is a set of high upvoted Reddit articles. It was about 40 gigabytes of text data, and was enormous compared to GPT-1's dataset. GPT-2 also used 1.5 billion parameters, which were 10 times as many as the number of parameters GPT-1 had. However, perhaps the feature that distinguished GPT-2 from GPT-1 the most was task conditioning. Task conditioning allows GPT-2 to make different outputs for different tasks from the same input. This was the start of making a general-purpose language processing model that anyone could use. GPT-2 had an impressive debut, outperforming state-of-the-art language processing models in zero-shot tasks. It proved that more parameters and a larger dataset allowed language processing models to give more coherent and accurate responses. It laid a solid foundation for GPT-3, which is the language processing model everyone is familiar with today. A little over a year later, in May 2020, OpenAI released GPT-3, which was leagues ahead of its predecessors GPT-1 and GPT-2. This expanded our understanding of what can be achieved with AI. Popular generative software such as ChatGPT and DALL-E are based on the GPT-3 language processing model. GPT-3 was trained on over 45 terabytes of text data from 5 different datasets, including WebText2, Common Crawl, and Wikipedia. It boasts an impressive 175 billion parameters, which is 10 times that of GPT-2. This allows GPT-3 to provide more seamless and accurate responses to prompts with minimal fine-tuning. OpenAI also tested contextual learning with GPT-3, which uses past conversations to better understand prompts and perform tasks. This is what enables ChatGPT's incredible human-like responses. GPT-3 represents a significant advancement in AI and machine learning. The model outperformed all existing language models in zero-shot tasks and performed exceptionally well in tasks such as unscrambling words, writing news articles, correcting code, and solving arithmetic. GPT-3 continues to evolve, and DALL-E and ChatGPT are actually versions of GPT 3.5, an improved version of GPT-3. GPT 3.5 has demonstrated improved ability in responding to prompts in a human-like manner, providing more accurate responses, and even performing abstract tasks such as writing music or poetry. The rapid advancement in OpenAI's GPT technology have left many wondering what the future holds. Will we soon see the emergence of truly lifelike androids? Let us know what you think in the comments, and stay tuned to learn about the latest developments in GPT-4 and discover its fatal flaw. Also, make sure to like this video and subscribe to Performance AI to always get the most out of your tech. A lot of hype has been building around GPT-4 and its potential capabilities, but some are concerned that this hype may ultimately lead to disappointment. Rumors suggest that OpenAI may train GPT-4 with 100 trillion parameters, which would be akin to flying too close to the sun like Icarus. However, the numbers don't add up. GPT-3 required the use of 1,024 GPUs, 34 days, and $4.6 million to process 175 billion parameters and 45 terabytes of data. A model with 100 trillion parameters and the corresponding amount of data, using 10,000 GPUs, would take 53 years and an astronomical amount of money. This issue arose from a study published by OpenAI titled Scaling Laws for Neural Language Models. The study claimed that for models to scale effectively, the number of parameters needed to increase more rapidly than the size of the dataset. In fact, their analysis revealed that a 5 times expansion of the dataset required an 8 times increase in model size. Additionally, they claimed that, given a specific compute budget, it is more efficient to train large models quickly than small models slowly. This revolutionary research suggested that scaling models faster than the size of the dataset was the key to improving performance, leading to the development of larger models with 175 billion parameters, such as GPT-3. Megatron Turing NLG has 530 billion, and Gopher has 280 billion. However, the promises made about these larger models were not kept. Today, we know that training sets and models need to be scaled in equal proportions. For every double in model size, the training tokens should also be doubled. DeepMind researchers tested this theory by training over 400 language models with different parameters and sizes of datasets. These findings led them to estimate that OpenAI should have trained GPT-3 on 10 times the amount of data that was used. This would have made GPT-3 compute optimal. To support their findings, the researchers at DeepMind developed Chinchilla, a language model that was 2.5 times smaller than GPT-3 and had 5 times the dataset size. Chinchilla performed better than GPT-3 in tests, showing that we can achieve more with smaller, less expensive models if they are trained with more data. Now, it appears that OpenAI has taken note of the problem with GPT-4 and may be working to solve it. Details about GPT-4 have been shrouded in mystery, but it is expected that OpenAI will release this model in late 2023. When this language processing model is eventually released, it is also expected to be a significant improvement over previous models. According to the CEO of OpenAI, who has warned us to manage our expectations, GPT-4 will not be much bigger than GPT-3. OpenAI may be trying to develop a more effective model that can accomplish more with roughly the same number of parameters. Is this possible? With rumors circulating that GPT-4 will have 100 trillion parameters, we can only wait to find out. However, one thing is certain: GPT-4 will accomplish much more than previous models. GPT models have had many issues that make us question whether they will be taking over the world soon. For one, GPT-3 has shown that artificial intelligence is not always so intelligent. GPT-3 is known to form long, incoherent sentences and even repeat text. Critics have also proven that ChatGPT is still incapable of understanding context and sentences. Even more concerning is the evidence that GPT-3 shows signs of religious, gender, and racial bias, inherited from the very human datasets on which it is trained. Hopefully, this bias can be eliminated in GPT-4. While a language model with 100 trillion parameters is unlikely to be developed anytime soon, GPT-4 can still be impressive. A more feasible version of GPT-4 might have the same number of parameters as GPT-3, but with 10 times the dataset size. It may also be able to receive data in multiple forms, such as images and sound, in addition to text. It seems that OpenAI recognizes this as well, with Sam Altman stating in an interview that GPT-4 will only be slightly bigger than GPT-3. Whatever GPT-4 ends up looking like, it will be a step forward in the development of artificial intelligence. Well, there you have it. Our thoughts on the fatal flaw of ChatGPT-4 and why AI might not yet be where we want it to be. Do you think OpenAI will build a larger model or stick to the same model and increase the dataset? Leave a comment saying larger model or same model to let us know your opinion. Finally, if you enjoyed this video, please give it a like and subscribe to Performance AI to always get the most out of your tech. Oh, and click on the video on screen right now to see what the YouTube AI wants you to watch next. See you next time.